You have to be careful when you're looking for patterns in the data with a graph. Now, we've already seen one way that you can go wrong there. Just assume that because two things correlate, they must be related causally somehow. Mortality due to spider deaths, remember, correlates with the number of letters in the winning word on a national spelling bee. And that was true for 10 years running, but it still doesn't mean that there's any connection at all between spider bites and the number of letters in the winning word. Correlation does not imply causation. That's data abuse number one. Data abuse number two would be change your data to fit your conclusion. Now that's a cardinal sin in science. It's a complete inversion of the way science is done. When the data doesn't fit the conclusion has to be discarded or modified. You can't warp or bend the data to fit your conclusion. That's called fudging the data or massaging the data or cooking the data. Whatever you want to call it, it's one of the more serious forms of scientific fraud. And when it's discovered on a professional level, it can mean the end of your career in science. But the most common form of scientific fraud is cherry picking, selecting only the data that fits your conclusion. So take a look at this graph here on the left. It shows global average temperature change over time. There are many ways that you can legitimately question this graph. How was the global average change defined and calculated? What was the data that was used? Temperature change of what? The ocean, the atmosphere, the land? What kind of methodology was used? Now, all of those are reasonable questions to ask, but the graph shows an obvious upward trend starting in the first quarter of the 20th century. It goes up. And in fact, more than 24 reconstructions of this graph by several different research teams using many different methods and measures of global temperature change all show this same hockey stick shape. The graph itself doesn't say anything about why global average temperature change is rising. But some have denied that the graph actually shows an upward trend. How can you do that? Because it shows an upward trend pretty plainly. Well, what they'll do is they'll pick only data that shows a downward trend. So they'll pick this data in here, or they'll pick this data in red here, which when you fit a line to it will show a downward trend. Now, if you fit a line to the red points only, there isn't any upward trend, but that's dishonest because there's no objective basis for you selecting only that subset of the data. If you're going to group the data, you have to have an objective, logical reason for doing it. You can't do it just because it fits your conclusion. So that's data abuse number 3. Data abuse number 4 is extrapolation. Extrapolation is the assumption that your conclusion holds in situations where you haven't actually collected any data. I wouldn't say this was scientific fraud, but it's very risky business. If you take a look at this graph on the right, it directly led to the deaths of the crew of the Space Shuttle Challenger. The graph shows estimated failure probabilities for something called O-rings. These were seals between the joints of segments on a rocket booster. The colder the seals the O-rings got, the stiffer they got, and the less effective the seal became. Now that allowed some of the hot gas to escape from inside the booster through the joint, and that had absolutely catastrophic results. The rocket booster fell apart during launch. Now in the morning of the Challenger launch, only the data on the right side was available. Only this data right here and these 2 points were available. We didn't have this data here at that time. The O-rings hadn't been tested at the temperature of the morning of the Challenger launch, which was 36 degrees. It was only later that this line and this line were obtained, which actually show the relationship between temperature and the O-ring failure probability. So if you only had this data over here, you might conclude that there's really no relationship between O-ring failure and temperature. and you just maybe average these and draw a straight line over here and say, well, there is a probability that they can fail, but it's always a probability that they can fail. So go ahead with the lunch. And that was exactly what the administration did. And that had very tragic results. The point is that when you don't have any data in a region where you're making conclusions, you need to be very, very careful. So this is called extrapolation, and you need to be very mindful of it. We're going to do an activity later in the course where we do extrapolation. Now, remember those 4 data abuses: confusing correlation with causation, fudging the data, cherry picking, and unwarranted extrapolation. Now remember those when you're asked to critique scientific results in some of our group activities throughout the course.